Number 10. Apollo 1 Fire, January 27, 1967. On January 27, 1967, a flash fire erupted inside the Apollo 1 command module during the launch rehearsal test at Cape Kennedy Air Force Station Launch Complex 34, killing astronauts Virgil Gus Grissom, Edward White, and Roger Chaffee. The crew was sealed inside the spacecraft conducting a plugs-out pre-flight countdown simulation when the fire began at approximately 6:31 in the evening. The command module was pressurized with pure oxygen at the time, which provided a fast-burning fuel source that caused the fire to spread rapidly through combustible materials inside the cabin. Technicians rushed toward the sealed spacecraft, but before they could reach it, the command module ruptured from the intense pressure and heat, and thick black smoke filled the room. Emergency procedures called for a minimum of 90 seconds to open the complex inward opening hatch, and the crew was overcome before they could complete the escape sequence. Rescuers reached the spacecraft 5 minutes after the initial alarm and found all 3 astronauts dead from asphyxiation caused by inhaling toxic gases, including carbon monoxide with thermal burns as a contributing factor. A 7-member review board under NASA Langley Research Center Director Dr. Floyd Thompson conducted a comprehensive investigation and completed a final report in April 1967. Although no single ignition source was conclusively identified, investigators believe the fire most likely resulted from an electrical fault in vulnerable wiring beneath Grissom's footrest. The investigation led to major safety modifications, including removal of flammable materials from the spacecraft, redesign of the hatch for rapid opening, change to an oxygen-nitrogen atmosphere mix for launch, and revisions to quality control and emergency procedures. Number 9. Vladimir Komarov, Soyuz 1 parachute failure, April 24, 1967. Soviet cosmonaut Vladimir Komarov launched into orbit aboard Soyuz 1 on April 23, 1967, from Baikonur Cosmodrome, piloting the first crewed flight of the Soyuz spacecraft. Shortly after launch, one solar panel failed to unfold, leading to a shortage of power for the spacecraft systems, and Komarov tried unsuccessfully to orient the Soyuz module for 5 hours. After the flight director decided to abort the mission, Soyuz 1 fired its retrorockets after 18 orbits and re-entered the Earth's atmosphere. First, the drogue parachute was deployed, followed by the main parachute. However, due to a defect, the main parachute did not unfold, and when Komarov activated the manually deployed reserve chute, it became tangled with the drogue chute, which did not release as intended. The Soyuz descent module fell to Earth in Orenburg Oblast, almost entirely unimpeded at about 40 meters per second, crashing into the ground after re-entry on April 24, 1967. A rescue helicopter spotted the descent module lying on its side with the parachute spread across the ground on fire, and by the time they landed and approached the descent module, was in flames with black smoke filling the air and streams of molten metal dripping from the exterior. It was obvious that Komarov had not survived, but there was no code signal for a cosmonaut's death, so the rescuers fired a signal flare calling for medical assistance. The official finding is that the drogue parachute did not apply enough force to pull the main parachute free, and a backup parachute was deployed manually by Komarov, but it fouled in the drogue chute and did not open sufficiently to break the craft. On April 26, 1967, Komarov was given a state funeral in Moscow, and his ashes were interred in the Kremlin Wall necropolis at Red Square. Number 8. Soyuz 11 depressurization, June 30, 1971. On June 6, 1971, the cosmonauts Georgy Dobrovolsky, Vladislav Volkov, and Viktor Patsayev were launched into space aboard Soyuz 11 on a mission to dock and enter Salyut 1, the Soviet space station, and the cosmonauts spent 23 days orbiting the Earth. When they fired the explosive bolts to separate the Soyuz 11 re-entry capsule from another stage of the spacecraft during re-entry on June 30th, a critical valve was jerked open, causing the cabin to lose pressure at an altitude of 168 kilometers. As the capsule rapidly depressurized, Patsayev tried to close the valve by hand but failed, and the rapid depress led to loss of consciousness of the crew despite attempts by one of the crew to block the leakage of air from the vehicle. They were not wearing pressure suits, and the cause of death was determined to be asphyxiation due to cabin depressurization. On June 30, 1971, as Soyuz 11 descended back to Earth, communication with the spacecraft was lost, but the capsule landed safely in Kazakhstan. When recovery crews opened the hatch, they discovered all 3 cosmonauts dead, and attempts to revive them failed. The Soviet Union conducted an extensive investigation into the incident, and the faulty valve was identified as the primary cause of the depressurization. As a result, significant design changes were made to subsequent Soyuz spacecraft, including the addition of pressure suits for cosmonauts during launch and re-entry. The Soviet government honored the cosmonauts with a state funeral, with NASA astronaut Thomas P. Stafford representing the President of the United States. Number 7. Challenger explosion, January 28, 1986. On January 28, 1986, the Space Shuttle Challenger broke apart 73 seconds into its flight from Cape Canaveral, Florida, killing all 7 crew members aboard. The spacecraft disintegrated at 13 a.m. local time at an altitude of approximately 46,000 feet above the Atlantic Ocean. Liftoff had been delayed until 11:38 a.m. on a morning when Central Florida experienced unusually cold temperatures. The disaster was caused by the failure of an O-ring seal in one of the solid rocket boosters, which did not respond as expected because of the cold temperature at launch time. The crew cabin separated from the orbiter during the explosion and hit the Atlantic Ocean at approximately 207 miles per hour, with the cabin not found until March 7, 1986. The crew compartment containing human remains and other fragments from the shuttle were recovered from the ocean floor after a 3-month search and recovery operation. President Ronald Reagan appointed a special commission, headed by former Secretary of State William Rogers, to investigate the disaster, with members including former astronaut Neil Armstrong and test pilot Chuck Yeager. The Rogers Commission identified the physical cause as the failure of the right solid rocket booster's O-ring seal, due to low temperatures, but placed primary emphasis on flawed management practices, including NASA's prioritization of schedule, over safety. As a result of the findings, NASA did not send astronauts into space for more than 2 years as it redesigned features of the space shuttle, with flights resuming in September 1988 with the launch of Discovery. Number 6. Columbia disintegration, February 1, 2003. On February 1, 2003, the Space Shuttle Columbia disintegrated as it re-entered the atmosphere over Texas and Louisiana, killing all 7 astronauts on board. Columbia had launched on January 16, 2003 for mission STS-107, a 16-day science mission featuring numerous microgravity experiments. 81 seconds after launch, a piece of foam insulation broke off from the shuttle's external propellant tank and struck the edge of Columbia's left wing, damaging heat-resistant tiles on the leading edge. At approximately 9 a.m. Eastern Standard Time on February 1st, the shuttle broke apart at an altitude of 60 kilometers, showering debris across southeastern Texas and southern Louisiana. More than 25,000 people from 270 organizations searched 2.3 million acres in eastern Texas and Louisiana for human remains and debris from the shuttle. The remains of all 7 astronauts were recovered, largely within a 5-mile area, and forensic specialists identified them using DNA. On March 27, 2003, a search helicopter crashed due to mechanical failure, killing pilot Jules Muir Jr. and Texas Forest Service aviation specialist Charles Krennick. The Columbia Accident Investigation Board released its final report on August 26, 2003, concluding that the tragedy was caused by technical and organizational failures, including the known problem of foam debris shedding that NASA management had considered acceptable. NASA suspended space shuttle flights for more than 2 years and implemented all the board's 29 recommendations before returning to flight in July 2005. Number 5. Theodore Freeman T-38 bird strike crash, October 31, 1964. On October 31, 1964, NASA astronaut Theodore Freeman was killed in the crash of a T-38 jet, marking the first fatality among the NASA astronaut corps. Freeman was returning from McDonnell training facilities in St. Louis and crashed during final approach to landing at Ellington Air Force Base in Houston. A goose flew into the port side air intake of his NASA-modified T-38 jet trainer, causing the engine to flame out. The bird strike was plainly observed by 2 airmen on duty in the Ellington Air Force Base Air Traffic Control Tower cab. Freeman attempted to land on the runway, but realized he was too short and might hit military housing, so he banked away from the runway and ejected. The jet had nosed down a considerable amount, and he ejected nearly horizontally. Freeman's parachute did not deploy in time, and he died upon impact with the ground. His skull was fractured and he had severe chest injuries. At 10:58 a.m., Dr. Charles Alden Berry, chief of the Manned Space Flight Center Medical Operations Office, declared Captain Freeman dead at the scene. Investigators found blood and feathers in the cockpit, and on November 12th, a search recovered the remains of a snow goose, along with fragments of the T-38's canopy, approximately 3 miles southeast of Ellington Air Force Base. Number 4. NASA T-38 Crash Street Lewis, February 28, 1966. On February 28, 1966, a Northrop T-38 Talon from NASA crashed at Lambert Field in St. Louis, Missouri, killing 2 Project Gemini astronauts, Elliot C. and Charles Bassett. The two aircraft took off from Ellington Air Force Base in Texas at 7:35 a.m. Central Time, with C in the lead and Stafford in wing position. Weather at Lambert Field in St. Louis was poor, with rain, snow, and fog, broken clouds at 800 feet and a cloud ceiling of 1,500 feet, requiring an instrument approach. At 8:58 a.m. Central Time, the plane struck the roof of McDonnell Building 101 on the northeast side of the airport, lost its right wing and landing gear on impact, then cartwheeled and crashed in a parking lot beyond the building. C and Bassett died instantly, and several McDonnell employees suffered minor injuries. NASA immediately appointed a 7-member panel to investigate the crash, headed by their chief of the astronaut office, Alan Shepard, and while the panel weighed possible medical issues, aircraft maintenance problems, weather conditions, and air traffic control factors, their end verdict was pilot error. The panel ruled pilot error as the primary cause due to the pilot's inability to maintain visual reference for a landing. Since the crash did not affect spaceflight operations and the spacecraft itself was undamaged, it was shipped to NASA 2 days after the crash, and the accident caused neither delays nor engineering changes in the U.S. space program. However, the loss of the Gemini 9 crew did cause NASA to reshuffle the crew assignments for subsequent Gemini and Apollo missions, and Stafford and Cernan were moved up to the primary position for Gemini 9A. Number 3, Clifton Williams T-38 mechanical failure, October 5, 1967. On October 5, 1967, NASA astronaut Clifton Curtis Williams Jr. was flying a T-38 jet trainer from Cape Canaveral to Houston, with a planned stop in Mobile, Alabama to visit his father who was dying of cancer. A mechanical failure caused the aileron controls to jam on his T-38 jet trainer near Tallahassee, Florida, causing an uncontrollable aileron roll. The jet was flying at 6,800 meters when it performed a sudden roll to the left and dived into the ground, almost straight down, at 1,125 kilometers per hour. Williams ejected at 450 meters altitude, but the plane was traveling too fast at too low an altitude for the seat to land safely. The aircraft dove straight down between pine trees 100 feet apart and crashed without touching them, although it did singe them from a fire caused by the crash. The aircraft crashed in Florida, near Tallahassee, within an hour of departing Patrick Air Force Base. At the time of his death, he was assigned to a backup crew with astronauts Charles Pete Conrad and Richard Gordon, training as lunar module pilot for an Apollo mission to test the LM in Earth orbit. He was the 4th astronaut from NASA's Astronaut Group 3 to have died, the first 2 having been killed in separate T-38 flights, and the 3rd in the Apollo 1 fire earlier that year. In his honor, on Alan Bean's suggestion, the Apollo 12 mission patch had 4 stars instead of 3, 1 for each of 3 astronauts, and 1 for Williams. And Bean placed Williams's naval aviator wings and silver astronaut pin to rest on the lunar surface during his moonwalk. Number 2. Michael Adams, X-15 Flight 191 breakup, November 15, 1967. On November 15, 1967, Major Michael James Adams of the United States Air Force was killed when the North American X-15 hypersonic research rocket plane broke apart during Flight 191, which was Adams' 7th flight in the X-15. The X-15 was launched from a Boeing NB-52B Stratofortress at 10:30 a.m. Pacific Standard Time over Delamar Dry Lake in Nevada at an altitude of 45,000 feet. Adams reached a peak altitude of 266,000 feet, which exceeded 50 miles and qualified him as an astronaut by United States Air Force standards, and achieved a speed of Mach 5.20. During ascent, an electrical disturbance from an experiment package degraded the aircraft's control system, and the inertial flight data system computer malfunctioned as the X-15 climbed through 140,000 feet. The aircraft began to drift in heading during a planned wind-rocking maneuver, and by the time it descended to 230,000 feet, it had yawed 90 degrees to its flight path and entered a violent Mach 5 spin. Adams radioed ground control that the aircraft seemed squirrely and reported that he was in a spin, but no recommended spin recovery technique existed for the X-15 at supersonic speeds. Adams recovered from the spin at approximately 118,000 feet, but found himself in an inverted Mach 4.7 dive, and as the X-15 plunged through thickening atmosphere, it experienced more than 15 G vertically and 8 G laterally, exceeding the aircraft's design limits. The X-15 broke apart at approximately 62,000 feet, 10 minutes, and 35 seconds after launch, and Adams was killed when the forward section impacted the desert near Johannesburg, California. A NASA accident investigation determined that the root cause was an electrical disturbance from an improperly qualified commercial component in an experiment package. and concluded that poor pilot-aircraft interface design and ineffective operational procedures prevented recognition and isolation of the failures before loss of control became inevitable. Number 1. Robert Lawrence, F-104 training crash, December 8, 1967. On December 8, 1967, Robert Lawrence was killed in an F-104 starfighter crash at Edwards Air Force Base, California, at age 32. Lawrence was flying backseat as the instructor pilot for flight test trainee Major Harvey Royer, who was learning the steep descent glide technique. Royer made such an approach but flared too late. The airplane struck the ground hard, its main gear failed, it caught fire, and rolled, the canopy shattered, and the plane bounced and skidded on the runway for 2,000 feet. Major Royer ejected upward and survived with major injuries. The back seat, which delays a moment to avoid hitting the front seat, ejected sideways, killing Lawrence instantly. He was still strapped to his ejector seat, his parachute failed to open and was dragged 75 feet from the wreck. Lawrence had flown many tests in the F-104 starfighter to investigate the gliding flight of unpowered spacecraft returning from orbit, and NASA cited him for accomplishments and flight maneuver data that contributed greatly to the development of the space shuttle.